Okay, for this problem, let's see if I can get the pen going. Okay. We've got the secant of 5 theta divided by 4 equals 2, and we're asked to solve that on this interval of 0 to 2 pi. So I would look at this first as being the secant of some angle, we'll call it x, is equal to 2. And then think back to my unit circle. In the unit circle, we learn the sine and cosine of these basic angles, and one that we should recall is that the cosine of 60 degrees is equal to 1/2. And we also know that cosine and secant are reciprocal functions, so I can take this expression right here, the secant of some angle equals 2, and think of that as the cosine of some angle equals 1/2. And then just looking at the first quadrant of our unit circle, where does the cosine of an angle equal 1/2? Well, that's at 60 degrees. But everything here is in terms of radians, so let's write that in terms of radians. So the cosine of pi over 3 is equal to 60 degrees, or is equal to 1/2, because pi over 3 equals 60 degrees. Now, I also know that cosine is positive in 2 quadrants, the first quadrant and the fourth quadrant. So using that pi over 3 as a reference angle, in the fourth quadrant, I also know that this is going to be true for subtracting 1/3 from 2 pi. That gives me 5 pi over 3. So that's just looking at this very simplified looking problem here. Now, what we've got to deal with is the fact that our angle is not just x. Our angle is 5 pi over 4. So I'm going to replace this x here with 5 pi over 4, and then I have to consider that I could be looking at multiples of 2 pi. I could keep on revolving around this unit circle. So I'm going to say something like 5 pi over 4. Let me write it down here. 5 theta over 4, excuse me. Is equal to, going back, just replacing x with 5 theta over 4, pi over 3 plus multiples of 2 pi. So to write that, to show that I may keep revolving around that unit circle, I'll write like this, plus 2 pi k. And then in a moment, I'm going to make some substitutions for k. Then I also have to think about the other angle. So I've got 5 theta over 4 is equal to 5 pi over 3 plus some multiples of 2 pi. Now, to solve these equations for theta, what I need to do is multiply both sides by 4/5, right, to get rid of this 5/4. So if I multiply the left side by 4/5, all this stuff's going to cancel out. And whatever I do on one side of the equation, I've got to do on the other. So I'm going to multiply pi over 3 by 4/5. And I'm also going to multiply 2 pi k by 4/5. So now what I have is theta is equal to, multiplying this together, 4 pi over 15 plus, and multiplying this together, that's going to be 8 pi over 5k. And I do the same type of thing over here, multiplying both sides of the equation by 4/5, and that's going to give me for theta, theta equals 4 pi over 3. Plus 8 pi k, or 8 pi over 5 times k. So these are my two answers in general form, but I'm asked to solve over this interval from 0 to 2 pi. So all I want is just answers in that interval. So if I replace k with 0, what I end up with as two of my answers are 4 pi over 15 and 4 pi over 3. Okay, so I'm going to just go ahead and jot those two down. So replacing k with 0, one of my answers is 4 pi over 15. And over here, another answer is 4 pi over 3. Now, if I go back and replace k with 1, then another possible solution would be 4 pi over 15 plus 8 pi over 5, get a common denominator of 15. That changes this numerator to 24 pi plus 4 pi. So now I've got 28 pi over 15. That's when I replace k with 1. If I replace k with 2, then that makes this 16 pi over 5, and get a common denominator by multiplying this, both the numerator and denominator, by 3. So that's 48 pi over 15 plus 4 pi over 15. So that puts me at 52 pi over 15. Now that's a problem, because here this 52 pi over 15 is greater than 2 pi. So I'm not going to include this in my answer. So I can just stop with those two. Over here, I do the same thing for 4 pi over 3. I'm going to add on, replace the k with 1, get a common denominator of 15, add those two together. That's going to give me 24 pi over 15 plus 20 pi over 15. So that's a total of 44 pi over 15. Just replacing k with 1. And here again, I've got the same problem. 44 over 15 is going to be greater than 2. So that's greater than 2 pi, so I'm not going to use that as an answer. So my answers for this problem are 4 pi over 15, 28 pi over 15, and 4 pi over 3. Those are my three solutions. I hope this helps.